This parabola has a vertex at 3, -1, and it passes through this particular point 1, 7. Second parabola has its vertex as 1, 4, and a y-intercept of 3. And I want you to find the approximate coordinates of the points at which these parabolas intersect. So bottom line here is you know that from this section, if you have two equations, you can either substitute, eliminate, or use your graphing calculator to find the intersection points. But the problem with this question is, what are the two equations? So we're going to do and try to find the two equations. I hope you remember the stuff from good old chapter 3. y2 minus y1. What's that mean? Vertex? What?
Isn't that vertex?
How about P and Q, your vertex?
Oh.
I think you're doing slope, y2 minus y1.
Oh, is that slope?
Kind of, not really. But we'll talk about that later. Do you remember this thing? Yeah, this is the vertex form of the quadratic function. Isn't it great to do some review? So here we go. What's P and Q?
Couldn't you have two different equations then?
Yeah, you could, but they represent the same thing, right? I just choose this form because I gave you the vertex, so I thought it'd be easier this way. So the first part, let's do this one. I guess we have y equals to a, and can someone help me out with P and the Q? What's P? Okay, so it's 3, so x minus P is x minus 3, yeah. And then the Q value, minus 1, so let's get rid of that plus sign. All right, we have to also find out a, okay. So we use our other piece of information. I will say let's plug in the point 1, 7. Let's find a. 1 minus 3 all squared, take away 1. Do the stuff in the brackets first. 1 minus 3 is -2. -2 squared is 4, I believe. So I'll put the 4 in front. Okay. Do some quick algebra. I know you guys all love algebra. Add 1, 8. And so I believe a just equals to 8 divided by 4, which is 2. All this, I shouldn't really box that. All this to get the equation y equals to 2 bracket x minus 3 all squared minus 1. Okay. Wow, that was just the first equation. First parabola. There's another parabola. What? I know. Practice makes perfect. Okay, so go ahead and try to do the next one on your own, please. Okay. Let's see if you can do it on your own.
Same formula?
Sure, you can use the same formula. Yep. Use the same formula. All right, so we're solving for the next one here. We get a equals to -1. Can someone confirm to me that the second parabola equation is y equals to -x minus 1 all squared plus 4? Yeah? Okay, that's good.
So are we done?
So are you done? This is just the beginning. Because now you have your two equations, and now it says what are the approximate coordinates of the points at which these parabolas intersect.
Also solve for x.
So now you have to solve for x and y, right? Now you have two equations, and you want to put them together to find the intersection points. Okay, so all this work, and now let's try to solve. Okay, let's now solve the system of, and this is a quadratic-quadratic equation, right? Quadratic equations. Now, ladies and gentlemen, which way do you think is the best way to solve this one?
Oh, 1 equals 2.
Yeah, so what does that mean? What method is that? Substitution, elimination?
Substitution.
Substitution? Sure. Okay. So we'll substitute the y value in. Okay, so I'm going to take the 2x minus 3 all squared minus 1, right? That's the one in black. And since that equals to y, I'm going to substitute that for the other y, -x minus 1 all squared plus 4.
And you solve for x.
And you solve for x. Have fun. Let's do some algebra. Okay, now, really, this stuff's not too hard, but people will be in trouble because they don't do the algebra correctly, okay? Or they'll make mistakes like a negative sign and whatnot. So just be careful when you do this chapter, okay? Take it slow and steady, make sure you don't miss out anything, and then everything should be fine, okay? Okay, so you work on yours, I'll work on mine, and hopefully we'll get the right answer in the end. And if you're already finished, go chat with your neighbor to double check you guys are both correct. So let's see, I will put everything to the left side, so 3x squared, and then negative 14x, 18 minus 1, 17, 17 plus, that's just back to 18, 18 minus 4,
22.
Is it 14 or 22?
Because it's
Isn't it 14?
14.
Is it 14?
Yeah.
Okay. Can I factor this one? Two numbers that multiply to 42 and add to negative 14.
Or use the quadratic formula.
Yeah, so quadratic time, right? Can you factor this one? Has someone tried to factor this one? Let's use the quadratic formula then, okay? Use the quadratic formula to solve for x. X equals to negative b plus or minus square root of b squared minus 4ac all over 2a. 196. Oh no, what's this? 4 times 3 is 12. 12 times 14. What's 12 times 14? 168? Okay. What's 196 minus 168? 6, 2, 8. 28? Oh. Is it 28? Chang, is it 28? Okay, yeah. Now, remember how we can simplify this? And I know this is nasty. Oh, it says approximate coordinates. Oh, that's okay then. Time to bring out your calculator. Approximate coordinates. So can you calculate what these two values will be? Okay. Yes.
Can't you like reduce square root 28?
You could, but I would not reduce like this, Vincent.
Oh, okay.
You have to rewrite the square root of 28 as a mixed radical first. So if you want to reduce it, okay, if you want to do it as an exact answer, then I would say, what's 28 equal to? Well, that's the same thing as 4 times 7, so that's 2 root 7, okay? And then I would reduce from here. This, divide everything by 2, right? So that'll be 1, so then I think if you wanted, this would be the reduced form.
But it doesn't matter if you do it.
You don't have to, especially in this one where I said, I just want you to find the approximate coordinates anyways. So approximate means decimal, so forget that. Just go ahead and find out what this is right now. Somebody help me, please. What are my values for x? And I'll use x1 and x2 to show the two different answers. 3.215. Okay, what's the other one? 1.45. Okay. Now, ladies and gentlemen, here's the fatal mistake that I see many people do on their tests. They find x, they're done. Woo! Oh yeah, you're solving a system of equations, so your answer should involve x and y. So now go ahead and find y, please. So what's the corresponding y for 3.215? Now, you have lots of choice. You can put it into any of the equations, the black one or the blue one. I will probably suggest you put it into the black one because it looks a little bit easier. But if you want to try the blue one, you're more than welcome to. I should not be lazy. I should do this myself. So let's do this too. So let's plug it in. Let's see what you get. Ooh, pretty graph. So what do we have here? Do you remember that little trick I told you last time?
You're graphing.
I don't know if you remember this, but you can plug in 3.125 and store it as x. Yeah. Now, if you do it like this, and I'll show it to you again, on your graphing calculator, all you have to do is just type in the actual function, 2 bracket x minus 3, close the bracket, squared minus 1. And if you press enter right now, the calculator knows to substitute in x for the number 3.125, and it will get you the answer for you. Okay, negative 0.96875. So negative 0.96875. Now you're thinking, Mr. Lee, why would I want to do this? Well, don't forget, there are two values of x, right? So guess what I do now? If I want to find the next one, I'll just type in 1.45 and this store key again, which is the arrow. So I'm going to store it in the value for x. It now replaces it. And then now, to get back that function, you can type it in again, or you use second enter, and second enter again to recall the previous entry. Press enter, and boom, there you go, 3.805. Okay. Try it on your calculators. It's great. Now, one last thing I want you to be aware of. Please make sure you write your answers as coordinates, and of course put them in order. So do x first, then y. So 3.215, comma, negative 0.96875. How do I do the what, sorry, Dia? How do I put the function in? Just type it in. Oh, getting it back. It's the second enter key. You see this little word entry it says? So that recalls the previous entry, but you might need to do it 2 or 3 times to get the one you want. So second entry, second enter, second enter. Okay? All right. Done. By the way, this one here, star it, because this is an extra tricky one. Extra tricky. But you should understand the idea. I believe you had questions in your homework that said find the tangent point, right? So when you had a line and a parabola, if you did it, you should number 19. Okay. I know Linda did it, so ask Linda if you're not too sure how to do it. All right, ladies and gentlemen, what can you do for this one? Plug in? Plug in what? Y value, sure. So let's try to substitute again. So you want me to plug in the y into which equation? Like I've got two equations, number 1, number 2. Which one do I want to do? Am I plugging 1 into 2 or am I plugging 2 into 1? 2 into 1?
No, 1 into 2.
1 into 2?
Wait, no, can't you just solve for y on 1 and then make them equal each other?
Okay, so that's fine. If you want to solve for y for 1 and then make them equal to each other like I did for number 1, that's perfectly fine. Now, if you think that's an extra step and you just want to substitute 2 into 1, that will be good too, and I'll show you what it looks like. So you get 4x minus, instead of y, you're going to have all that lovely stuff. Okay, so you're going to have 16 over x squared minus 1. Okay. By the way, Edison, your way works too. So if you like that one, do that one. Okay. Now, some of you are shaking your boots. You hate fractions, right? Yeah. So how can I get rid of this fraction here? You what? Multiply by the fraction, denominator. Sure. So I'll say to get rid of the fraction, let's just multiply by that denominator. So we'll multiply all terms by x squared. Okay, so that's 4x times x squared is x cubed. Huh? You can't have a cube. Let's just keep going first. Shame on Anna, she lied. Okay,
Wait, why can't you have x cubed?
we'll find out.
Oh, because it's quadratic. Quadratic can have.
Okay, we'll find out soon enough. Okay, you didn't lie. It's a plus x squared. Thank you. Thank you. Thank you. Okay. And Anna, along with the rest of you, are freaking out because you're like, it's x cubed, it's not quadratic. I know. I know. What's Mr. Lee doing to you? Factor out of 4 looks prettier. Okay. Get rid of that 4. The unlucky Chinese number of 4. Yes. And it looks a little bit prettier. All right. Okay. Remember how I said today's like review? Yeah. Say that louder, Bronte. The factor theorem, remainder theorem, stuff. What?
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 What is that?
What is that?
Divided.
Is it like the big division?
Huh? That's the stuff we did when we did some extra stuff in chapter 4. Let me just quickly find it for you. Yeah, right. Remember this stuff? The long division. Remember?
What the fuck is this?
Okay, now, let me just tell you right now. Shh. Let me just tell you right now. I will not ask you on our test to do something like this with long division. But I did want to take this opportunity to review something that you will need to know for next year. So I thought I would just spend a few minutes right now to do this. Okay? Now, I'm going to say to solve algebraically, okay, see the notes from your chapter 4 extra stuff. You lost it? Download it again. Still online. Okay? But not for long. I'm running out of space. Gotta take stuff off. Yes. So selfish, Katie. All right. Now,
Yeah, we're more important. Obviously. What's special?
you know that you're recording this right now, right? The whole world will see.
It's okay.
Okay. So, how are you going to solve this algebraically? Now, once again, I'm not going to ask you to do this in your test, so don't freak out, but I thought I'd review it one more time with you, okay? Now, what you want to do is you want to find out your first factor, and you have to look at the last term. So you ask yourself this, okay? What factors multiply to give you negative 4? 4, yeah. What else? 1, what else? 2. Now, don't forget, it's negative 4. There actually is plus minus, plus minus, plus minus. Okay? Now, which value is a 0? So what you need to do now is you have to pick one of these factors and plug it in to your equation. And your equation that I'm going to plug into is the easier one, this one here. And see if it equals to 0, because you're trying to find a 0. Can anyone spot which number works quite nicely here? 1. Yes. See, I picked nice numbers for you. So let's try x equal to 1. And when you plug it into the equation, the one that I highlighted in yellow, you'll notice that this equals to 0. Yay! That means it's a factor. And then what can you do after that? Divide the thing by x minus 1. Yeah, so that's a factor. So therefore, I'll say you take x minus 1, and then you do that nice long division stuff. Okay. And now be careful when you do long division. You see how there's no x term? I always tell you to put in a 0. Kind of like how you say the number 1005, right? You don't go 1, 5. You go 1, 0, 0, 5. And then it's now time to do some long division. And if you're not too sure how to do this, that's okay. I will do this with you again. Ask yourself this. We'll take x. X times what gives you x cubed? X squared, yes. And then you take x squared times x minus 1, so we get x cubed minus x squared. And then like any other long division, we subtract, subtract, subtract. So 3 minus negative x squared is 4x squared. Bring down the 0x. Okay. What's next now? X with 4x squared. What goes into that? 4x. Okay. 4x squared minus 4x. What do we have next? We subtract. We get 4x minus 4. What's next? 4. Right, x times 4. Lovely. Lovely. Oh, life is good because your remainder is 0. If this is not 0, you start to cry because you did all that work and you got it wrong. Okay. Ladies and gentlemen, so what you have done by doing this lovely work is you've factored the cubic, okay? Not Julia, okay? Okay, so you've got x minus 1, and you've got this lovely factor now, x squared plus 4x plus 4. So once again, I'm saying that the stuff in the highlighted boxes are the same, the equivalent form. Okay? And of course this equals to 0. So I guess I should put a 4 in front, and I could 0. Okay? Now, ladies and gentlemen, you're trying to solve for x, so you're still not done solving for x yet. Oh, what can you do with this lovely 3-term trinomial? Make it like a thing, like with the binomial. Yeah. Help me out. What two numbers multiply to 4 and add to 4? 2. 2. X plus 2, x plus 2, x minus 1 equals to 0. Okay. So what's my value for x? X equals to 1. And then over here, I got x equal to negative 2. Now, once we find x, don't forget you should find y. It's easy to find y. Which equation would you like to plug it into to find y? Number 1 or number 2? The first one? Okay. I thought the second one would be easier, but because the first one you saw, okay. I just think the second one's easier because it has y equals 2 already, right? And what's y for x? 4, 3, right? Okay, so what do we have here? Our solution is...
Isn't there only one solution?
Okay. Welcome to extra tricky land. Okay. Now, Anna's saying back there, she's scratching her head. She's going to lose her hair soon. Right? She says, wait a minute, Mr. Lee. You said show this is tangent, and we got 2 answers. But you said tangent means there's only one intersection point. So what is going on? Now, like, you're not being punked. I don't do that kind of stuff. Okay, now, can we all bring our graphing calculators right now? Okay. I'm going to show you, and this one is a really, really interesting one. Okay. Now, once again, I won't put a question like this on the test, but I thought I'd show you anyways. Okay. Go and plug the graph in. Okay. So, what are my equations? I guess I got the first one here of, oh, I have to solve for y, don't I? 4x plus 11. Okay, so 4x plus 11. That's what Edison says. 4x plus 11. And the other one is 16 divided by, now put a bracket around here, please, x squared minus 1. Okay. So once you get that in, let's graph it out. Let's see what you get. Graph. There's my line. Where's my parabola? Uh-oh. Let me go to my standard window. Is that better? Okay. Let me make this picture look even nicer. Let's change our window. Y max to maybe like, I don't know, 20. Okay. So ladies and gentlemen, why is this one, why does this one have two answers when I say show this tangent? Okay, look at the graph. Is your graph look like mine, by the way? Okay. Turn back to my equations. 4x plus 11 for Katie. Did you put 16 divided by with a bracket around the x squared? Minus 1. Is your window like mine too then? Negative 10, 10. Negative 10, 20. Let's take a look together. Good, never mind. So, ladies and gentlemen, what am I talking about here when I say tangents? Okay. Which point is actually my tangent point? Is it the one that's the left? Right. So the one on the left represents actually this value over here. Okay. So this is actually my tangent point. Okay. This other one here is actually an intersection point. Okay. Now, what I want you to understand is the reason why we've got this intersection point on the other side is this graph that I gave you for number 2, 16 over x squared minus 1, is a, bless you, is a rational function. So we've got that weird stuff going on. We got the asymptote, okay? But really, the idea of a tangent, and let me see if I can explain this to you. You don't need to write this down. You'll probably get a more formal reasoning behind this when you take calculus next year, okay? This can be a question done with calculus, right, Bronte? Yes, okay? So what I want you to understand is this, okay? Can you watch my little arrow here? This line seems to only touch this part of the parabola at one particular point. Agreed? Okay? Now, you're thinking, how could I have seen that in my algebra over here? Well, what you could have seen is this. Most of the times when you factor, the factors here, and I'll circle them, these factors are usually all different. Agreed? But this one, look, two of them were the same. Now, when they are different, what that means is you should have not just one, not just two, but three different intersection points. Agreed? So this line could have been moved like over here. Okay? And if I moved it to up here, you'll see it crosses at two, or it intersects at 2 points. But what happened when I made them the same? That means those 2 points got closer and closer and closer and closer together. Okay? Just like this. Let me try to draw, okay? Here's your curve. We start off with a line which has 2 points. Of course, that's not tangent. But if we move those 2 points closer and closer together, okay? Oh, that's still not close enough. How about here? That's still not close enough. But once I make those 2 points pretty much right on top of each other, then you get that tangent line. Well, how do I show that 2 points are on top of each other in the algebra? That's where you have that x minus 2, or sorry, x plus 2, x plus 2. Okay? So because this has what they call two factors of the same thing, we can know that this is a tangent point. And I'll say due to the two factors of x plus 2. Okay? Now I know once again you think, whoa, how would I have done this in tests? Don't worry, it's not testable material, but I thought I'd show it to you now. The beauty of what you're learning right now too in grade 11 is you're going to see all this stuff again in calculus. Okay? Learning how to substitute and solve, this idea of tangents, factoring, this is all not in vain, okay? There is purpose behind the madness that we do in grade 11. Okay. All right, do you want to take a quick break first? No? Keep going? All right then, turn the page. Let's do this. By the way, these are a fair game, okay? 3 and 4 you should know how to do. Okay? All right. Ladies and gentlemen, this one says find k, there's only one solution. AKA one solution means it's like a tangent line again. Okay? Now, once again, because you're only finding one solution, I guess you're trying to solve for the coordinates. In this case, what would you like to do? substitution, elimination. What do you prefer?
Substitute.
Really? You guys love substitution, don't you?
Yeah.
Isn't this one easier if I just do elimination by adding the two equations together? Okay. Now remember, go to the online assignment thing, or not online assignment, online website, and there are questions that ask you which one's easier to do, substitution, elimination. Practice that.
Substitution.
By the way, both methods work, but one's much easier. Now, Edison, your question is how do you add x squared plus 6x together? They're different. You're right. So just write down x squared plus 6x. Okay. The y's, of course, cancel out now. And then on the right-hand side, 25 plus k. Good. You can put a bracket around there if you want, sure. Okay, because these are constants. Now, once you get to this stage, you're thinking, how do I show that there's one solution? Well, here's what I'd like you to do, first of all. When you try to solve questions, you always try to move everything to one side. So just like how you solve with numbers, let's move all the terms to one side. Okay. And this is supposed to equal to? 0.
Well, why don't you just put 25 over to one side and you solve for k?
Good luck trying to solve that, because you have x and you have k. And you have x squared. That's the nasty part. Remember we have x squared and an x term? You have 3 terms, so I usually like to move everything to one side and do some factoring. Ah, okay. How do you factor this? I don't have that last number, do I?
Make sure the last number has to be 9.
Okay, Vincent says here, the last number here, this last number must be, oh, -9 or 9? Which one?
-9, because it's a...
Oh, so okay, you're saying this part here then.
Yeah.
You're saying this part here must be 9, or -9. How'd you get -9?
Because your answer, there's only one solution, so it'd be perfect square.
Oh, okay. Listen up. He just said that, hey, since there's only one solution, your answer or your factors here, okay, your expression, I'll say, your expression must be a perfect square. Good. Hey, now we're doing a review of like completing the square stuff. Oh, yeah.
You're funny.
So, how do you know it's 9 though if it's a perfect square? Remember when we did questions like this before? Where we had like x squared plus 6x, what number must be a perfect square to make this a perfect square?
9.
Half of the 6, which is 3, yeah. And then we square it, which is 9. Yeah. So Vincent, smart of him, said that, hey, this whole number here must be 9, but because there's a negative, that means that bracket must equal to -9. Awesome. So then you just now go ahead and take that bracket, which is 25 plus k, make it equal to -9, and solve for k. So k equals to -34. Congratulations. Now you might be thinking, Mr. Lee, how come there's so much empty space on the side?
Oh, we could check.
Let me show you another way. If you were not as bright as Vincent, and you can see that that's a perfect square, here's another way you can do this, okay? So, other way, another way. Okay, remember, this is like review today. How do you know if a quadratic equation, which is what I have here, has one solution, no solutions, or 2 solutions? Say that louder, Bronte. Louder. Fine. Bronte and Victor joined together forces to say the word discriminant. Whoa, but what is that discriminant for those of us who don't review?
It's the -b plus minus 4ac.
Yeah. Quadratic formula, it's the stuff underneath the square root. b squared minus 4ac, right? Now, if I want one solution, what must the discriminant be equal to? Ah, yes. b squared minus 4ac equals 0 for one solution. So by the way, on a test I could change this to find k so there's only 2 solutions, and then you'd have a greater than sign, less than sign, right? All that good stuff. Oh yes. Kitty's getting a headache because she's like, there's so much to review. Okay? Now, using this discriminant, what's b? What's a? What's c?
Oh, you use that original formula.
Yeah, use this. What's b? Tell me what b is. 6. Good. 6 squared. minus 4. What's A? 1. What's C? Okay, now C is this whole thing. The negative with the 25 plus K. That whole thing is my C, my constant. And this is supposed to equal to 0. All right, time to solve. 6 squared is 36. The two negatives here become a positive. And then I've got 4 times 25 plus K equal to 0. Okay, most of you probably want to just distribute this out. Hello, hello. Okay, ladies and gentlemen, did you solve this yet? Did you solve this? Did you solve this? Yeah? What'd you get? Yeah, you bet. Should be the same thing, right? If it's not the same thing, we're in big trouble. Okay. All right. Katie, thanks for telling the whole world you're below average. Okay, let's do number 4, please. Okay? Shh. Number 4, please. Okay? Challenge galore. I love this one. Mr. Lee likes this one. Okay. Ladies and gentlemen, this one's nasty. Let's take a look together. Hey, this is a system of equations, right? This one has 2 variables, right? But it's so nasty. How do I solve this one? Yeah, my favorite F word. Let's factor. Can you factor anything from the first equation here? Let's call this number 1. P. Let's do it. 1 plus r squared equals 26. Can you do anything with the second equation that I'll use green? P squared r. Okay, so we'll factor out p squared r.
And then they get the same.
They get the same?
No, the same 1 plus r squared.
Oh, they get the same 1 plus r squared. Ooh. Okay, so despite, ladies and gentlemen, this question having 2 variables and lots of different confusing things, we both now actually seen something that's similar in both equations. So I don't know if you want to do this as an extra step, but you might want to now just solve, okay, for 1 plus r squared. So if I just want that by itself on the left side, what would I have done with that p in front?
Divide it.
Divide it. So it goes to this side, it becomes division. So 26 over p.
Wait, Mr. Lee.
Yes, Vincent.
Can you divide the first equation by the second?
Yes, I'll show you that in a second too. Okay. I'm just doing this way. Mr. Vincent over here said, hey, can I just divide the equations? I'll show you that in a second as well. If I were to do the same thing and solve for the 1 plus r squared for the second equation, then what we have on the right-hand side for the second equation is 156 over p squared r. Okay? Now, why would I do that?
Make them equal each other.
Yeah, now they make them equal each other. So now you can say, hey, so now we can make 26 over p equal to 156 over p squared r. How's that going to help me out?
Cross multiply.
Oh, okay, cross multiply? Sure. So 26p squared r equals to 156p. I guess one of the p's can cancel out. That's pretty. What do you want to solve for, p or r? P? Okay. So 26pr equals to 156. P then equals to 156 over 26r. Does 26 and 156 have something in common? Is it 6? Nice. 6 over r. All that work to get you p equals to 6 over r. Now what can you do? Now it's time to substitute. Where would you like to put this p equals to 6 over r? The first one, second one?
The first one.
Yeah, so let's substitute p equals to 6 over r into equation number 1. And I'm going to ask you to do this now on your own, because I want you to have the exciting challenge of doing this. It's not exciting, I heard.
It's pretty exciting.
It's pretty exciting.
This is better than the last chapter.
Oh no, we will have to distribute. Oh, let's get rid of that r first of all, right? 6. Oh, this one's not too bad. It's just a quadratic. No cubic here. Anna, you're safe. No cubic. No cubic. Yep. All right, ladies and gentlemen. It's just regular algebra now. 6r squared equals to 26r. Wow, so many 6's. 6r squared minus 20r plus 6. I think it's time for you to finish this off. Try on your own, please. 3r minus 1.
And 2r.
2r minus 6. What? Really? 2r minus 6? Oh yeah, okay, yeah, that makes sense. Or use the quadratic formula, yeah. R equals to 1/3, R equals to 3. Is that what you got? Okay, that's good, that's good, that's good. How do you solve for P then?
Plug it in.
Plug it in. Yeah, 6 over R, right? So 6 divided by 1/3 is 18. And then here, 6 over 3 is 2. Now, here's a dilemma that many of you asked me. Mr. Lee, this is not X and Y, so which one goes first? Well, these are letters in the alphabet, right? There's an order to the letters in the alphabet, right? So which letter comes first, P or R? Huh? P comes first. So whatever comes first, we usually write as the first coordinate. Now, ladies and gentlemen, if you really want to be specific, because you're thinking some people might not know what letter comes first, okay, here's what you can do. You can write down a sample coordinate like this. We'll say P, comma, R, and then we'll say this equals to, and then list them out. So P is 18, R is 1/3, or we'll say P is 2, R is 3. So ladies and gentlemen, by doing it this way, when you write out the P comma R, that tells the reader that your first variable, or your first coordinate is P, and your second one is R.